So first I'll start out by explaining what aneuploids are, as well as the difference between monosomies and trisomies. So aneuploids, they have, it disrupts the natural balance of gene products in cells. So an aneuploid cell has an abnormal number of chromosomes. So each chromosome contains hundreds of genes. So when you lose with the addition or loss of one of these single chromosomes, it just disrupts the entire cells and is a lot of times really it just kind of disrupts the entire thing and is not always compatible with like a normal functioning life. So monosomy is when an organism has only one copy of a chromosome that should be presented in two copies. So, and then trisomy is when an organism has a third copy of a chromosome that should be present in two copies. So just some differences between the two of them. So aside from what I said, so they're represented by different formulas per se. So monosomy is represented by parenthesis 2n minus 1, close parenthesis. I mean, I guess you don't really need parentheses in there, but, and then the trisomy is represented by 2n plus 1. So then just like an example of one of the two for monosomy is Turner syndrome as an example, and then for trisomy, Down syndrome is an example. So that's just kind of the overview of those two things and what exactly the just a brief explanation of what the two are and how they're a little bit different. So then also going into the next question about nondisjunction and how it creates aneuploids. So I'll explain the first and second phase. So disorders of chromosomes, these number disorders are caused by nondisjunction. So it occurs with a pair of homologous chromosomes or sister chromatids, and when they fail to separate during meiosis 1 or meiosis 2. So when this happens, as I stated before, gametes with an abnormal number of chromosomes are produced. So in meiosis 1, it would occur differently than it would in meiosis 2. So in meiosis 1, the normal diploid cell is 2n equals 4. So it's two pairs of homologous chromosomes. So one pair of homologous chromosome does not separate during meiosis 1, but then the rest of meiosis continues normally aside from that, the homologous chromosome not separating during the first meiosis. So the end result of this is all the gametes end up with abnormal number of chromosomes, as this definition is, and two have 3 chromosomes, and then the other 2 only have 1 each. And so that's how you end up with those aneuploids in meiosis 1. In meiosis 2, the normal diploid cell is 2n equals 4, so 2 pairs of homologous chromosomes. Meiosis 1 occurs normally, and then you get to meiosis 2, and a pair of sister chromatids fail to separate, so they remain combined. So the end result is 2 normal gametes, 2 with 2 chromosomes, and 2 abnormal gametes, 1 with 3 chromosomes, and then 1 with 1. So then just the two, really just kind of reiterating, the failure for the failure for meiosis 1, when that happens, it's a failure of homologous chromosomes to separate towards the poles during anaphase 1. This is known as non-disjunction in meiosis 1, like I stated before. And then the summary of the second one is when there's a failure of sister chromatids to separate during anaphase 2, and this is known as non-disjunction in meiosis 2. And then as far as the sister chromatids go, homologous chromosomes fail to separate properly in meiosis 1, and then sister chromatids, I keep saying that, I probably said it this entire time, fail to separate properly in meiosis 2. So that's everything as far as you wanted an explanation for. I will submit this video and then I'll attach a document like I did in my last one, just kind of with those references I used as well.